Hi, we're Team What a Disaster. The main goal of our project was to display the history and trend of natural disasters from 1960 to 2015. This information is useful to a variety of users, but we focused on a few target audiences. The first group of people we aim to target are those involved with disaster preparedness, namely government agencies, insurance agencies, and individual organizations such as the Red Cross. Other groups of target audiences include people looking for new places to move to, contractors or engineers involved with design and construction of buildings, geologists, and people willing to donate for natural disaster relief. Imagine that you're a government agency that has to plan the budget for natural disaster preparedness. According to the module provided by the National Association of Development Organization, the government should be able to identify the natural disasters with potential financial implications for the community based on likelihood of occurrence and the cost needed to recover from the disaster. With huge amounts of data, it would be hard to find the data you need. To make this easier, we built a visualization to help solve this problem. We have three visualizations: a map view, a bar graph, and a line graph. On the map view, each country is shaded to encode the average yearly ratio of number of people affected over the total population. This shading shows users relatively safe and unsafe countries alike. Next, upon initial loading, the bar graph shows the number of people affected for each of the different types of disasters for the entire world. Using the drop-down, the user can also look at the number of deaths, total cost of damages, and the number of occurrences for each disaster type. Next, the line graph shows the frequency of disasters for each year. All three of these visualizations are linked together. When one clicks a specific country in the map view, the bar and line graphs only show data for that particular country. Similarly, clicking on a specific disaster type in the bar graph will make the map view and the line graphs only show data for that specific disaster type. At any time, a single country and single disaster type can be selected together. Finally, adjusting the ends of the slider at the bottom of the screen will make all three visualizations only show data for that time period. All linking information will be available in the Help tooltip on each visualization. This will make it easy for new users to use the visualization properly. Finally, clicking the Reset button on the top resets all of the graphs. Through our visualization, we intend to answer some general questions that all our target audiences might have. The first general question is what types of disasters are more likely to occur within the country. To answer this, the user could click on a specific country. Let's say we choose Peru. The user can then select frequency in the drop-down of the bar graph to determine the most common disaster types. Here we see that floods are the most common, with total number of occurrences of 51. Another general question is how likely is it for floods to occur in the future? To answer this, we need to analyze the line graph. For this demo, we want to see the frequency of floods for the past 20 years. We would need to click the flood bar on the graph to filter by disaster type, and then slide the slider to set the year range from 1995 to 2015. We can see that a flood has occurred 28 times in the past 20 years, so it's likely that a flood could occur this year. We also intend to answer specific questions that our target audiences might have. Disaster preparedness agencies might ask questions like, which disaster type should have the highest priority in terms of preparedness? For example, agencies might look at total damage caused by each disaster type in the last 20 years to determine prioritization. Let's take Spain, for example. To do this, the user can first click Spain on the map. The user can then drag the slider bar to 1995 and then click Total Damages in the drop-down. The user can then see from the bar graph that in the past 20 years, droughts caused the most damages to the country, totaling $3.2 billion. Accordingly, Spain's disaster preparedness agencies could conduct community preparedness programs to teach the population how to handle drought emergencies, in efforts to reduce the damage and number of people affected by drought. The other question that the agencies might have or which countries are the most vulnerable for certain disaster types and at the highest need for preparedness. The user can reset the visualization and choose a certain disaster type from the bar graph. For example, let's say we choose earthquake. The user can now see that Chile and Peru are the darkest red color, which means that they are the most vulnerable country and need the highest priority for disaster preparedness. Let's reset the visualization and go back to Peru. Insurance agencies in Peru might be able to use the visualization in a similar way. They, however, want to determine the additional coverage costs for specific disasters. Just like before, they would first click on Peru on the map, click Total Damage on the drop-down, and then drag the left slider to 1995. From the bar chart, we can see that earthquakes cause much more damage than storms. Accordingly, they can charge higher for earthquake coverage than storm coverage. Furthermore, people intending to donate for natural disaster relief causes can use the same visualization to determine which disasters need the most financial attention. In this case, earthquakes need the most financial attention. Next, individuals looking to move to new areas and contractors involved in new building construction might also wonder where are the safest countries and what are the risks of living or building in certain areas. To find safe locations, they could look on the map to see which countries are shaded darker versus which countries are shaded lighter red. They could then use the bar graph to determine future risks by looking at cost of damages and number of people affected for certain areas. Finally, geologists might wonder what are trends in natural disasters over time. The sole purpose of our line graph is to determine trends in the frequency of natural disasters over a specified time period and/or for a specific country. They could also filter the line graph by disaster type to see the frequency trend for certain disaster types. Overall, our visualization answers many questions regarding the trend of natural disasters, preparedness, and relief.